Hi everyone. Good morning and good evening. And today we are going to discuss about DNS. Okay, the one which I'm highlighting every time, right? Like you know, when you type, this is a Google Chrome. Okay, when you type www.tungabhadranetworks.in and I'm clicking on enter, what exactly is happening at the back end? What exactly will happen? Do you understood? I mean, like my question. So those
First, it will send.
It will like this is on like on the application layer itself, then it will change to the IP address of that site and then
yeah, we'll
that.
discuss. We'll discuss now. So you understood, right? The question. So how exactly it will happen? And if you see it practically here, when I'm trying to ping tungabhadranetworks.in, okay, when I'm trying to ping tungabhadranetworks.in, it is connecting, it is getting a reply from IP address. Okay, it means whatever the domain you want to create, you can create it. You can create palkrishna.com, chiranjeevi.com, whatever it is, the name. Okay, here this is my company name. I created my domain. Okay, and each domain everyone is accessing and it should be in public, right? That's why I purchase a public IP. This is my public IP. I purchased it from IANA organization. Okay, and I gave to my domain. So now systems cannot understand these keywords. Okay, system cannot understand the alphabetical keyword. System only understands zeros and ones, and this is the IP address. Is it clear, everyone? Hello.
Clear.
Yeah.
System only understands zeros and ones. So whatever it is, not only my domain, you can ping google.com also. Ping www dot whatever the domain you can see. Google also have a public IP. Every website will have a public IP. Okay, it cannot understand. Okay, the question is, I'm trying to ping Google and it is getting reply from IP address. How exactly it is happening? Okay, you said system cannot understand IP addresses, sorry, domain names, and it will only understand IP addresses. Now it is converting IP address to domain name to IP address. It is called DNS. So this is called DNS, domain name system. This is DNS name, domain name system. What it will do? It will convert from IP address. Sorry, it will convert from domain name to IP address, IP address to domain name. Some people say it will translate. Either ways, you can say anything. So systems cannot understand domain names. That's why it will convert from domain name to IP address, again back IP address to domain name. Okay, how exactly it is happening? Today we are discussing step by step. Okay, let's discuss the process. Okay, domain name system, or domain name server, whatever it is, you can call either ways. Okay, domain name system and domain name server. Okay, let's see this. Okay. And guys, this is a beautiful presentation which I have prepared. So concentrate now. Yesterday, one guy is asking he would like to understand the ports. Is he available today? Hello?
Sir, Nene sir.
Yeah, okay, cool. So now understand, this is very high level class. Now during demo class, before joining this internship program, I used to say, right, what will happen when you type something website on your browser? Now this is a perfect answer. So to understand this process, you must understand the basics. That's why I designed the course like this, like step by step. Now this is the time to understand the concepts clearly. Okay, now listen here. When you type www.tungabhadranetworks.in on your computer, what will happen? Each computer maintains the cache memory. Okay, it has its own cache. In that cache, it maintains this, IP address along with the, sorry, domain names along with the IP addresses. So I would like to tell you, there are records. So records are like, it will store some information. What information it will store? Record A, and record AA. Record A will store IPv4 address. Okay. Record A will store IPv4 address and record A will store IPv6 address. Okay. So whatever the address you need, IPv4 or IPv6, whatever the address you need, these records will store in A record, AAA record. Okay. So IPv4 will store in A record, IPv6 will store in AAA record. Understood? Okay, guys, this is a server concepts. We should not implement it, but you should understand the process. Okay, server engineers will take care of it. Being as a network engineer, you have to understand the process at packet level. Okay, so first, when you type a www.tungabhadranetworks.in on your computer, it will check its own cache. Hey, do I have the IP address for this Tungabhadra networks or not? Where it will check? It will check in its own cache, A regard and AA regard. So IPv4 or IPv6. Suppose talk about IPv4. It will check A record. Do I have the IP address for this Tungabhadra networks.in? It will check in its own cache. If it is there, okay, in case if it is already there, it will directly establish a TCP connection with Tungabhadra networks.in server, web server. It means TCP, right? It will establish a connection with that server TCP. Okay. So, you know, DNS uses port number 53, TCP and UDP. Okay, the application layer. Okay, DNS uses both port number TCP as well as UDP. When it will use UDP, when it will use TCP. So if the IP address is already there for this domain name, it will directly establish a connection with server. Okay, with the TCP connection 53. Okay, if it is not, what, anyone having any questions? Okay, so if it has the IP address for this Tungabhadra networks.in, it will directly establish a connection with the server TCP. What do you mean by TCP? Okay, connection. What do you mean by connection? Let's understand now. Okay, one second. Okay, so let me tell you this. Okay, TCP. I'll explain parallelly TCP as well as UDP, DNS. Okay, one second. Where is the TCP? Guys, are you understanding what I'm saying today? Hello?
Yes, yes.
Yeah,
Yes.
yeah. Okay. So see this diagram. Okay. TCP. TCP connection. So everyone knows, right? What is TCP? It's a transport layer protocol. Transmission control protocol. We have two transport layer protocols. One is TCP, one is UDP. So today I'm going to discuss about TCP as well. Okay. So see here how TCP works. So if you see the real-time packet capture, see this is a real-time packet capture, right? See, this is a real-time packet capture. The packets are divided into chunks. How many packets it is divided? This is a real-time packet capture. Okay. So, TCP or UDP, you will see, right? So suppose how exactly the TCP works. See here. So the Ramesh PC, it is my PC, local PC, and I have the IP address of so here it's not Ramesh Tech Library. One second, let's change. This is Tungabhadra Networks dot in server. Okay. Tungabhadra Networks. Okay, this is a server. Now see here carefully. So right, TCP. I told you to prepare the TCP header. Guys, it's very important to prepare TCP header. So I'm telling you again, you just learned source port and destination port. Now today I'm going to tell you this control flags also. Okay, one by one. Okay, where exactly it will come, I will tell you. Okay, okay. Now see how TCP works. So first, TCP, when you have a IP address for the server, right? So first it will establish a connection with the server. How it will establish a connection? First, PC will send a TCP packet. It will send entire TCP packet. In the TCP, you will see a lot of fields. What is the source port? Source port always be random. Okay, see here once again. Okay, uh, source port. Guys, are you getting what I'm saying? Okay, source port. See, you will have source IP, destination IP, and all. But here, let's concentrate on application layer, source port and destination port. Here, source port is random. Okay, and destination is 53, TCP 53. Okay, you will see right here source port and destination port. So top of below that you will see the okay. Let's okay. First source MAC, destination MAC, source IP, destination IP. Okay. Now it will generate a TCP packet. Here transport layer. It uses what is it? It uses TCP. Okay. Now in source MAC it will be Ramesh PC. Suppose Ramesh MAC address is AA and destination MAC address is the gateway routers. It is different network, right? It's gateway routers is BB, something like that. And source IP will be Ramesh IP address like 192.168.0.2 and destination IP address is Tungabhadra networks.in IP. Let's take real IP address here. Okay. So guys, are you getting what I'm doing here?
Yes, yes. Yes,
So
sir.
this is entire packet. So this packet will generate. It is established trying to establishing a TCP connection. See how exactly we'll get a water. First municipality will give you a pipe connections, right? Water underground through underground they will give you a pipe connectivity to you at your to your home. Then after they will release the water, you'll get the water. Similarly, to here the water equal to data. If you want to send and receive the data, first you have to establish a connection. So that's why we call TCP is a connection oriented protocol. So why it is a reliable protocol, why it is a connection and secure protocol. Okay, see here. So first it will try to establish a connection. So it will generate a packet here, and in transport layer, the source port always be random, and the destination port here TCP 53. Okay. Now, if it is a DNS server, it uses a TCP port number 53. It will always open a 53 port here. Okay. Now, in the control bits. So if you see right, these are the control bits. Whatever you see right here, these are the control bits. Here the sin means synchronization bit. Okay. First, when you try to establish a TCP connection, this synchronization bit set to 1. If it is set to 1, it means it is initiated a TCP connection. Who? Ramesh PC. This PC initiated a TCP connection stating that the sin bit set to 1. Sin equal to 1. Okay. Now this packet will send to Tungabhadra network server. Now server will see this. Hey, destination port number is 53. I am the DNS server. I opened it this port number 53. Also, I am the destination IP. Destination server is me only. Okay. I'm the this IP address is belongs to me. It's my IP address. Now this Tungabhadra network server will respond it. Same thing. So it will respond with it will roles will be reversed here. Okay. Here remove layer 2. Okay, let's discuss about layer 3. So here source IP will be PCs. Okay, server IP and destination IP address will be PC's IP. It's 0.2. Understood? It's a replay from server, and now it is a transport layer is TCP. Now source will be 53. Okay, and the destination is whatever random port it was generated, right? Like that one. Suppose random it is generated 20, it is 20. To not 20, you should not use that one. Some 35,100. Okay, something like that. 3,500 something. Okay, now it will respond sin plus ACK. Sin plus ACK. It means sin equal to 1 as well as ACK equal to 1. You can see the control bits right here. It is acknowledging it. Syn means synchronization. It is trying to establish a connection. Whatever the request it is came right here at the server, it is acknowledging it. Hey, I'm the server. Accepting your request by by setting this acknowledgement bit to 1. So it will send SYNAC. Once this SYNAC is received, again this Ramesh PC, hey, thank you for acknowledging me. I received your acknowledgement and this is my acknowledgement. Again, it will send an acknowledgement. Acknowledgement is ACK. Now, once it receives the acknowledgement, right now, three-way handshake process is completed. The session is established. This is how TCP will establish a connection with the server. First, it will send a TCP packet with SYN bit set to 1. Then server will respond with SYN plus SYNAC, and then and computer again will give an acknowledgement to the server. After completion of this three-way handshake process, the connection will be established. The SYN SYNAC ACK is called three-way handshake process. Okay, understood everyone? Anyone having any
Yes.
question here?
Yeah, I just have a question for the port thing that you told.
Mm-hmm.
Like, is that the
Yeah.
last line?
What do you mean by porting? Please define precisely.
mean, like you told me, like for the server port 53, and again
What is
there.
the DNS? What is the DNS port number? Port number? Tell me.
I don't know.
What?
Do not learn the port number
53.
actually. 53.
53.
You don't know the port numbers? It's a very basic on day one. I told you.
Yeah,
DNS port numbers. It's it is both
53.
TCP and UDP. It's 53.
Yeah.
How the electronic device can understand this is the protocol? They have their port numbers, each and everything.
Okay.
What is the HTTPS port number?
80.
Again, listen to my question carefully. HTTPS.
443. 443.
Yeah. So each and every service, each and every application service, they have their port numbers. Okay. That's how the electronics devices can understand. Now, if it is port number 53, it's a DNS, it's a domain name system. It's a domain name
Yeah.
server, right? If you configure this is as a server, it's always open this 53. It is 53 port number, TCP 53. Okay.
Okay.
It is TCP 53, it is open. Okay. Understood? So
Yeah.
చిన్న డౌట్ అది 50 ద పోర్ట్ నెంబర్ 53 అని ఎట్లా తెలుసు సార్ అదొక డౌట్ ఉంది అంతే.
why? No, man, it's already defined, predefined.
ఓకే సార్.
It is defined by IANA organization. You
ఓకే
can
సార్.
ask them. So they design like this. I told you, right? Why they divided IP addresses like that? That IANA organization did that. Okay. Similarly,
ఓకే సార్.
if even though I created one protocol and it needs transport layer protocol, right, to send the
ఓకే
data.
సార్.
Ramesh
ఓకే.
protocol, it needs TCP. So I need to contact IANA. Hey, I developed a protocol. I need a TCP port number for that. Can you please assign one port number to me? They will assign random port to me. I need to pay
ఓకే సార్.
amount and they will register it. Understood? Like that, DNS is
ఓకే సార్.
already registered with 53. Like that, other services
ఓకే సార్.
also. And I told you there are 0 to 1023. These are the well-known ports.
ఓకే.
Okay,
ఓకే సార్.
so these are the well-known ports. Okay, here it is. You can see well-known ports. Port number 0 to 1023 specifically well-known ports. It means already it is defined. See, certainly commonly used HTTP 80, HTTPS 443, DNS 53, SSH 22, like that. Okay, those are the well-known ports which is already defined. Okay, and other protocols, lot of protocols already registered, right? These are the registered ports like 10242 49151. Okay, it was registered by IANA between this range. So
We have
149,
around
sorry,
we have around 60,000 ports, right?
yeah, 65,535 ports, 2 power 16. Okay,
Mhm.
now remaining this, right, 49,152 to 65,535, those are the random ports for using source, right? Just now I told you, right?
Then
When
it
you
is
say,
difficult to
yeah,
remember that ports now. How it is possible?
no, it's not. It's easy to remember for the well-known ports. Okay,
Okay.
so when it
Only
is
well-known ports only have to remember.
well-known ports only we are using. Those
Okay.
are services. So whatever the dynamic ports, right? These ports are like when you're generating any packet, I told you, right? It will choose the random port. So
Mm.
it will choose a random port from here. Okay,
Who
here.
is generating random port here?
You tell me who will generating random port here? Please tell me.
Our application layer.
Why application layer? See, man, you have to apply your logic, brother.
Sorry, sorry.
Who is generating TCP packet? See, frame the question first. What I understood from you especially is you're not thinking properly. So you're generating a packet, right? Now you tell me. Just rephrase your question, you'll get an answer. So
Sir, PC.
yes, PC.
This
PC
only I
gen
need part.
yeah, PC generating a packet and while
NIC
entering,
card.
yeah, when entering all the fields, right? When entering all the fields, now you will see source port is random. Okay.
Network and network interface card will generate.
Again, I'm telling you, man. Again, I'm telling you. Your PC will generate. Okay. Not network interface card. The computer has its own operating system. When you're trying to connect DNS, right? The
Yeah,
DNS
that's one I
function,
know. But which part is generating in computer?
computer operating system, brother. You should say
Okay, right,
computer.
right.
That's what I'm also saying. The computer has that logic. They build the logic in operating system. When you're
Mm,
trying to generate DNS, right? So
mm,
whatever the application traffic it is generated by the computer, it
mm,
uses transport layer either TCP or UDP. When it is generating a packet, in
mm,
that packet you will see layer 2, layer 3, layer 4 fields. In the layer 4 field, who is entering all, it will check, right? In layer 2, it will check the ARP table, layer 3 destination IP, whatever you type,
mm,
and layer
mm,
4, whatever the service you are using, right?
mm.
Whatever the input you are giving, based on that it will behave, it will generate. Okay.
Okay.
Yeah. Fine. Okay. So the Ramesh PC will generate a TCP packet with SYN, and server will get a SYNAC, and again this PC will give a ACK. Okay. This is called three-way handshake process. Now, after completion of three-way handshake process, the connection is established. Now you can securely exchange the data. So here using, right, HTTPS. Securely again I can exchange the data. See, I'm clicking on Palo Alto here. I can see Palo Alto page. See now, right? I'm accessing the data. I'm clicking on CCNA. See, whatever it is, I'm clicking on Juniper. The data, whatever the data is there in each page, it's loading. The data is loading. In case the connection is not established, you will see 40 server error or 403 error,
Yes,
503
sir, yes, sir.
something, right? Right. That's the thing. First, the thing is TCP means first it will establish a connection with the server, whatever the server. It's a DNS server. Okay. Otherwise, it won't. Okay. So first it will establish a connection with the server. Then what will happen? It will send the data, in the stream of chunks. Okay. So how it will send the data? See here. Okay. Where is it? Yeah. First it will SYNBIT will send SYNAC ACK. This is three-way handshake process. Okay. This is three-way handshake process. Please remember it. They will ask you in interview how the computer will establish a connection with the server by using three-way handshake process. Can you please elaborate? Ante you have to explain, like, first it will send a TCP TCP packet with SYN bit set to 1. TCP packet with TCP packet with SYN bit set to 1. Okay. So let me open this for you. Okay. Uh, 1 second. Just a second. Sasra? Can you hear me, guys? Hello.
Yes, yes.
Okay. So once TCP connection is established, right? So the data will transfer. So you understood three-way handshake process clearly? Anyone having any questions?
No,
No,
no.
sir.
Okay, everyone, very important. Hello?
Yes,
Hello?
yes, it is clear.
So first, if you want to access the server, right? Any server, okay, DNS server. First, it will establish a connection, not only with DNS server. So these are the services, right? HTTP, HTTPS, and other services, SSH. Everything. If anyone using TCP, right? Okay, any service using TCP, right? So first, it will establish a connection with the respective device, the destination device, whatever it is, then only it will start accessing the data. Okay. Now here, can you please go on mute?
Device means
Please.
DNS, right?
Sorry.
Respective device means it will connect to DNS. It will.
Yeah. Just here I'm talking about DNS. Just and I give an
Mm,
example in DNS.
okay,
If
okay.
you're using SSH service, so it
Mm,
means you're trying to connect. You're trying to log in the device remotely by using SSH service.
mm,
First, what it will do, it will
mm.
establish a connection. Then only you will log in because it uses a TCP, right?
Yes.
Whoever is using TCP,
Everything is to TCP and UDP only.
what UDP, brother? Why you are mixing UDP?
99% the model is TCP only. No? That's why.
Yeah, yeah, I'm talking about TCP. Don't fuck the things, okay? So I'm talking about TCP only. So whoever is using TCP, it will
Mm,
establish a three-way handshake first. Okay?
mm.
Yeah,
Synchronize, sync, acknowledge.
yes, that's an important thing. Okay. So again, please go on mute, brother. Okay. Again, one more thing. So you guys simply saying that first computer will send SYN packet. No, you should say it will send a TCP packet with SYN bit set to 1. Understood? The PC will send a TCP segment. You should not call packet also. It's a segment, right? Layer 4, the data we call as a segment. So PC will generate a TCP segment with SYN bit set to 1. Then server will respond with the TCP segment with simplest hack. I will show you the packet capture right now. Okay. Yeah. So once it is establishing a TCP connection, right, it will start sending the data. Suppose you are trying to download one movie or trying to download one song or any video, any resumes, anything, the data you're trying to download from the server, right? Right now, right now, you logged into my rameshtechlibrary.com and you open this training videos and gave this IP address, right?
Yes.
Sorry. You try to give this password. Now you want to download this file from internet, from server. Tungabhadra networks.in is a server. These are the files which are there in the server. If you click one right, it is downloading quickly based on your internet speed. How it will download the file from server? You given a request, the server will download it to your PC. How? You cannot see entire data at once. First it will divide the file. Okay, suppose it is having 100 MB. Just consider. Okay, it is having 100 MB. This 100 MB divided into chunks. That's why it's called packet switching, right? TCP is called packet switching. I told you
Mm.
right on the day two. Do you
Divided
remember?
into method chunks.
Yes, chunks. Suppose it is divided into 25 MB, four chunks. Just an example. This is having sequence number 1. Okay,
Mm,
you can see sequence, right? Sequence,
mm,
sequence 1 like that. And now another 25 MB, it is sequence 2. Just an example. Another 25 MB, it's 3, right? Another one, it's 4. Okay, this is sequence numbers. Okay, these are the sequence numbers for each data. First 25 MB it will send to the computer. Once computer acknowledge it, hey, I received your first 25 MB, then it will start sending another 25 MB. And again it will start sending another 25 MB. Now 75% is completed. And when it's sending fourth chunk, the internet connection is lost. So what it will happen? It is not. It is waiting for the acknowledgement from the computer. Until unless it is getting acknowledgement only, then only it will send. If it is not getting, it will retransmit 25 MB again. Third chunk. Maybe third chunk is not delivered to the computer. Let me retransmit. So the server will think that and it will retransmit. Okay. And once we get the acknowledgement, it will send another fourth chunk as well. It means maybe sometimes internet is lost and it restored it and it retransmitted here. Server is retransmitted and computer will respond it, and last chunk will be sent to PC again. Okay, you understood, right? The thing is here, the data will split it in the form of streamed bytes. Okay, data chunks you can say, and each chunk one by one it will send it. Each chunk should get an acknowledgement, then only it will send the next stream of bytes. So like that, step by step it will send. Once it is downloaded, right, it will show you 100% is downloaded. And after 100% download also, it will take 2 seconds at least, because this will be received in an order, right? It will merge together in order way and it will display the original file. Okay, understood now how it works, the TCP?
Yeah, yeah.
Everyone? I
Yes,
don't
sir.
see. I don't think everyone understood.
Yes, Anna.
Everyone, please, raise your hands if you don't understood anyone. Everyone understood? Please ask me. This is very important. First, it will establish a three-way handshake process. Then the data will send it across this session. And now these are the control bits. What do you mean by control bits? Can you please confirm what you mean by control bits? Who will control your TV remote? Your remote? Sorry, what is that? Your TV, your home TV, and your AC. Who will control the remote? Right, the remote will
Yeah.
control. Similarly, this TCP session. This is called TCP connection. This TCP session is controlled by these bits. So how many control bits we have now? How many control bits we have here? 6. Currently, how many we discussed? SYN and acknowledgement, right? So SYN,
Yes.
it will initiate a connection and it will acknowledge the connection. Okay. If you want to establish a connection or terminate the connection, these are the control bits. Let's talk about push, pin, reset, urge as well. Okay. So let's finish this TCP now. Okay.
Yeah. How you said 6 bits?
Sorry.
How you said 6 bits?
How- Have you learned the packet header of TCP? Just asking.
TCP.
TCP packet header. Have you learned it? I told you on the day one. It's very important
Yeah.
to learn.
Source port and destination port. Yeah, I
I told
remember.
those are the two important fields. You have to learn other thing as well. So you will see, right? These are the
Mm.
so learn the packet header, please. Everyone learn the packet header,
Okay,
which is
okay, okay.
very important.
From
Okay.
URG to FN 6 bits, right?
Yeah. These are the control bits. So ACK
Okay.
means acknowledgement, and this is acknowledgement number, overall number. This is +1. You will see here. It is set to acknowledgement bit. Okay, I will show you right now with packet capture. Okay, with
Okay.
with real time SSH service. Okay, with real time SSH service. So just consider this is a device. This is a device. Okay, just consider it. Let it load. Okay, for some time. Okay, guys, so these are the very important. TCP is very important. Source port, right, it will be random. Destination port is whatever the, suppose I'm using DNS now. What is the destination port?
53.
Okay,
53.
suppose if I'm using SSH, what is the destination port?
22.
22.
Yeah, so it
22.
it means whatever the service you use, right, that will be in destination port. Okay, understood everyone?
Yeah.
The sequence number is the first one. So sequence number means each and every transaction, it has a one number here. Okay. Okay, if you see the packet capture, if you see TCP here, wherever you see somewhere you see, let's open TCP, real time packet capture thing. Yeah, TCP, right? This TCP, if you see, if you open TCP, so TCP is also a protocol. How the system can understand this is TCP? TCP also have a protocol number. ICMP protocol number. What is the ICMP protocol number? Come
One.
on, guys. It's one. ICMP. How computer comes to know it's ICMP protocol? In packet header, there is a protocol number. Okay. Here, protocol number. That protocol number will be one for ICMP, and TCP it is 6. How the system can understand it's a TCP protocol? The protocol number, based on the protocol number. The protocol number of TCP is 6. Again, protocol number of UDP is 17. Okay, each and every protocol they have numbers. Okay, like OSPF, BGP also they have numbers. I will tell you later. Okay, so now TCP, right? TCP, you will see sequence number here. See, source port is always random. Okay, and you will see these are flags. You can say these are the flags. Flags, control bits, all are same. If acknowledgement set to right, if it is set, it will equal to 1. Okay, and you will see the sequence number here. Sequence number always will be there. Okay, fine. And the window size, everything I'll tell you. Okay, first understand these are the control bits. Flags are right, control bits. So let me tell you this. Okay, one by one. After that, I will explain DNS. See why I'm explaining TCP here, because which is very important. Okay, which is very important now. Okay, guys. So whoever is not done Juniper, okay, they might not understand this device login. Okay, okay, anything, just forget it. I'm using SSH services. Okay, check this topology. Okay, I'm on router 2 and I'm trying to log in router 1. Okay, where am I'm on router, sorry, I'm on Juniper 1. Sorry, this is the router. This is a router. Are you seeing my screen, everyone? Are you seeing my screen?
Yes, yes.
Yes, sir.
Okay, see, first of all, if you want to establish a connection, it should reach, right? So now, see, this is a this is the IP address 1.1 for this device, and this device it is 1.2. First, let's ping 1.2. If it is reachable, then only you will able to connect the server. Okay, now it is reachable. Let me log in now. Okay,
Yeah, but we remove it.
please go on mute. Okay, see here, I'm trying to log in. Okay, see, I'm doing packet capture now. Start packet capturing. So what service I'm using now? What service I'm using? See the packet capture carefully. What service I'm using? SSH. What is the SSH port number?
Yes, yes.
What is
22.
this?
22.
22. Let's
Me
see.
too.
I'm going to explain the TCP with real time scenario. Listen carefully. This is very important because in interview they will ask you the control bits. When the SYN bit will set to 1, when the acknowledgement bit to set to 1, when the push bit set to 1. Each and every bit I'm showing practically now. Please focus on it. You cannot get this information in internet. You will see the verbal thing only. Right now I'm practically showing it so that you can easily permanently remember it if you concentrate on here. Please everyone concentrate this. Okay, see, I'm trying to log in router 2 from router 1 using SSH service. So SSH service is like for remote login. Okay, SSH, I'm giving a username. See, I'm trying to log in. See what it is saying. I have to give yes, something data displaying, right? Whatever I'm doing here, the data is displaying here. Let's give the password. Password is wrong. Okay, what is the password, man? Hmm. Okay, Okay, it's not establishing. Okay, too many password failures. Are you able to see something here? TCP, fin, ACK, something, right? Are you able to see here fin
Yeah.
finish? Yeah,
Yeah.
I will explain. I will explain each and everything because SSH uses. See, I'm using SSH version 2. The computer one. See, initially, see, it is trying to establish a connection with the server first. So who the 1.1 is trying to log in 1.2, right? See here, it is trying to establish a connection first. So that's why source port is always random, right? I told you the source port always random. The destination port is SSH, right? It's 22. Now in the flag bit, it is SYN bit set to 1. Everyone understood? It is trying to complete the three-way handshake process. First SYN bit set to 1, and then server is responding with SYNAC. See, hey, SYN plus ACK. See, SYN plus ACK. Okay. Now server 1.2 is responded, and now 1.1 is also responding with ACK. See, ACK. So if you see here, right? SYN, SYNAC, ACK. Three-way handshake process is completed. Connection is established. Now I need to enter the password, access the data. That's it. I need to enter the password, access the data. I'm not able to access the data because the password is wrong. That's why it is forcefully fin bit set to 1. Why fin bit set to 1? Because it's forcefully closing the connection. When you're trying to close the connection forcefully, the fin bit will set to 1. Fin means finish. The session is finished. You're trying to close the session forcefully. Okay. So let me log in again with the, see, you are seeing some packet capture. And again, SYNAC ACK. Let's see. Password. See, I logged in successfully. Okay. So I try to log in after giving this SSH service with SAIC user. Since SYNAC ACK is done, once I give it the encryption, right? Its encryption is accepted and acknowledged. Now I can see data. I'm on I'm on 1.2 router now. I'm on remote device. Guys, I understood. I tried to log in this router 2 from router 1. Now I'm able to log in successfully to router 2. Router 2 is 1.2. See, I logged in with Sai user. Now listen here. I'm typing something here. So it is reflecting here, right? I'm typing something in locally and it is reflecting in the packet capture. Are you understanding what I'm saying?
Yes, sir. Yes, sir.
Whatever
Yeah.
you type. Suppose if you take a team viewer or any desk, you're giving a remote connection and mouse, using mouse, you're trying to access the remote device so that you will see this data. Here also, I logged in the device remotely. I'm trying to some I'm trying to execute some commands. That commands is also a data and the data is showing here. It is encrypted and it is showing here. See here. Yes or no? So whatever I'm typing here, okay, okay, whatever I'm typing here, whatever I'm typing here, it's an urgent data for the application. Application in the sense SSH is an application service. Whatever I'm typing here, it should display on remote device quickly, right? Remote device is Junos 2, router 2. Okay, whatever I'm typing locally in my router, it should be display on remote device. Something like if you take a remote connection in your local computer, you can click on a mouse, you can click on any application on the remote device, it will be clicked based on your internet connection. Something if your internet connection is all not good, after clicking at your location, it will be it will be affected after 2 seconds, 3 seconds, like that. Have you observed this thing before?
Yes, yes.
Guys, other guys,
Yes,
are
sir.
you
Yes, sir.
understanding what I'm saying? So I logged in the device
Yes, yes.
remotely. So I'm trying to do, see, show version, I'm trying executed. See, whatever I'm giving, right? Space bar also. The data is executing here. Okay. It's important data. See, I'm executing show chassis. I'm trying to, whatever I'm executing the data here. See, the data is going through TCP. See here. Okay. If you open SSH, right? It's an urgent data. It's an urgent data. See, it's a TCP. We are using SSH protocol. Okay. It's an urgent data. SSH is a service, application service. The data, whatever the command you are executing, it should be reflect on, it should be sent to application, SSH application. That's why if you see the push flag set to 1, because when the push flag will set to 1, when the push flag will set to 1, whenever the router should send the data urgently to the application. Here you can see this is our 1.1 is our router. It is sending the data to SSH application protocol, SSH urgent basis. Whatever I'm typing here, right? Whatever I'm typing here, all the data is urgent basis because it should reflect quickly, right, on the remote device. It's urgent data, so the data will be, if whatever the data, it is immediately sent to the application, right? It will set the flag push. If the push flag will set to 1, it means the data should urgently sent to the application. Here, understood everyone? If you want to open any packet, SSH version 2 packet, open it. For all, it will set to push flag will set to 1 for all. Open any packet, see here also push flag will set to 1, because whatever I'm typing, see, when you will see this SSH version 2, see, I'm typing some, see, the last packet is OSPF something, it is showing here, right? I'm typing hi, see, I just type hi, it's quickly reflecting on the remote device through SSH protocol. See, it's I open, it's a push, it's urgent data. Hi is the urgent data. You should send through SSH. You will see push and acknowledgement. It means you're sending a data, and you acknowledge the server statement. Guys, understood when is push flag is set? Hello?
Yes, sir.
Yes.
Yeah, whenever
Yeah.
the real time example is for push flag is whenever you're trying to access the remote device from your local machine, in on your local computer you're typing some commands and it is reflecting on the remote device. So the data is traveling through SSH, right? SSH protocol. So the data is little urgent data which should immediately send to application SSH. That's why the push flag will set to 1 here. Okay, that's the thing. Now I'm trying to close the session. See, I'm trying to close the session. I'm trying to exit it. Now if you see,
Finish it.
right,
Everyone.
it set the fin black, because if you forcefully close the session, what will happen? It will finish. The F means finish. Okay, F means finish. It is if you forcefully closing the session, the finish flag will set to 1. Okay, understood now?
Yeah.
Finish bit. Okay, now I want to show you the reset bit. When reset bit will set to 1. Okay, suppose, uh, 1 second. So the thing is, suppose you did not configure SSH on remote device. Okay, you did not configure SSH on remote device, and there is no server enable, whatever it is, the service. There are two things, guys. Okay, you're trying to reach the connection. You're trying to establish a connection with the server. Okay, you're trying to establish a connection with the server. If it is DNS, if the port number is 53, if it is SSH, the port number is 22. But the remote end, there is no such a service. There is no SSH, there is no DNS. That is one case. And there is a DNS, but the port number is blocked. Okay, there is a router or some electronic firewall device is there. That firewall, the port numbers are blocked. Okay, it is not allowing to establish a connection, it is blocked. Suppose HTTP is not secure, right? It is blocked. So what will happen in that case? Okay, so the thing is the destination port, right? I told you source port is random, destination port is whatever the service you're using, that is a port, right? That port number may be blocked between, any transit device. Okay, from your computer to the server, there are a lot of networking devices, right? There may be a firewall also. That firewall is blocking the port number 53. If it is blocking for port number 53, it will not allow. That is one case. And there is no there is no such a service also. There is no such a DNS service or SSH service. Now I deleted the SSH service on router 2 so that you are not able to log in. Let's see the packet capture. Guys, understood what I'm saying? Hello?
Yes, sir.
Yes.
Okay. Let's see. This is a packet capture. So I'm trying to log in again. See, what is he saying? Connection is refused because I deleted the SSH service here. That's why it is refused. It means there are two things here. One is there may be port SSH port number may be blocked, or there is no such a service. Okay, and in that case it will set the reset flag. You can see red color. Not see reset flag. When the reset flag will set to 1, whenever the destination port will be blocked or the destination port respective service is not enabled, the the destination, the device will generate a TCP segment with reset flag. Hey, there is no such a service enabled here. Reset means there is no such a service enabled here, or it is blocked. You don't know it is blocked or it is not enabled. You need to identify. It is trying to establish a it is trying to establish a connection with SYN bit set to 1, but the remote device is denying it. Hey, there is no service here. How can you establish a service with me? There is no such a service. That's why it is stating that it will send a reset flag. How it is displaying connection refused based on this flag. This flag set to 1 and the computer will generate connection refused. Understood? I hope all the flags we covered except the urgent bit. Right?
Mm.
Right, everyone? See,
Yes.
you know SYN. Why? What is SYN bat? It is when you're trying to establish a synchronization. When you're trying to establish a connection, synchronization bit will set to 1, and you'll get acknowledgement, right? And push in the sense when you try to access the remote data, the urgent data will go to the application. I show you, right? The push flag will set to 1, and finish when you try to close the session forcefully, it will close by setting the fin bit 1. And now reset. If the service or the respective service port number is blocked, the reset field set to 1. And the only thing is urgent. When this urgent bit will set to 1, right? Whatever the data it is there in urgent pointer, it will go to the application. This thing I will explain later. Okay, just remember this. If this bit to set to 1, there is a 16-bit field here in urgent pointer. Whatever the data present in urgent pointer, that will go to application quickly. Okay, yeah, this all are about TCP, guys. High level. Please remember TCP. They will ask you in depth. And then TCP, there
Okay,
will
sir.
be a congestion control, flow control, error control. These are the TCP options. So TCP options, flow control, error control, congestion control, that you need to prepare. Okay, that is next level. Again, that is purely next level. So TCP options, prepare well. Okay, once you know this, you will easily learn. Okay, yeah, I will have a separate book. Okay, talk to uh, uh, there is a guy who explained DNS and TCP IP. I have a very big book. It's cost of 800 rupees. I have a electronic book. I purchased it. If you want, I will give it to you. Do you need that book? They explain very well about TCP and DNS. It's the biggest book. Do you need
It's
that?
for free or it's for
Yes,
paid?
sir.
Yeah, I'll give it to you after this class. Okay. Okay. Now you understood TCP, right, clearly. So when you have the IP address, then it will try to establish a connection with the server. It starts sending the data and receiving the data. Is it is it done now?
Yes, sir.
Hello.
Yes, sir.
Yeah.
Yeah, yeah.
Now, what if
Yes,
your
sir.
computer does not know the IP address? Just 10 to 15 minutes, guys. DNS will be completed because see, the TCP DNS are involved here because DNS is using both TCP and UDP. That's why I combine these two session in one class so that you can easily remember the things. Okay. So just 10 minutes more, it will be finished. Okay. So when you type www.tungabhadranetworks.in on your computer, first it will check, do I have the IP address for this tungabhadranetworks.in or not? If it is having it, right, directly establish a connection with server with TCP53 and it will start accessing the data. If it is not, what it will do? It will generate a recursive query. Now, what is query? Hey, I don't have the IP address for tungabhadranetworks.in domain. Can can you please give me the IP address? It is asking to whom? Tell me, the computer will ask to whom? To whom it will ask?
DNS.
DNS.
So if you see right, in computer, you may have DNS resolver. Okay, primary DNS and secondary DNS. So you configure this right here. So you see in TCP IPv4 stack, you will see IP address, subnet mask, and gateway, and you will see the preferred DNS and alternate DNS. These are the DNSs which are provided by the service providers. Each service provider, he maintains a server that is called DNS resolver. The service provider have all the information about domain names. Okay, so who it will generate a query for whom? DNS resolver. Okay, it will generate a query to whom? DNS resolver. So suppose my computer IP address is 192.168.1.1. Okay, just just think it. Okay, now tell me the packet capture. Okay, in IP address, the source IP is 192.168.1.1, right? Generally, what is the destination IP? What is the destination IP? Whatever the server you configure. What is the DNS resolver, right? What is the DNS resolver you configure? That the IP. Suppose that suppose the DNS resolver IP is some 192.168.1.100. Sorry. So the destination IP will be 192.168.1.100. It is not a gateway IP, it's a primary DNS IP, because it is asking, hey, I don't have IP address for Tungabhadra networks.in, please give it to me. Okay, yeah,
Okay.
okay. So it is asking to the DNS resolver by generating a recursive query. So UDP, it uses UDP now. So you know, right, DNS uses both TCP and UDP. It uses UDP.
Yes.
Source port is random again, and the destination port is 53. Okay, okay. So
Okay.
it will generate a recursive query to DNS resolver. The packet will come to the DNS resolver, and it checks the 1.100 is mine. Oh, you are asking for domain. So it is asking, right, a record a. Hey, can you please send me the IP address of Tungabhadra networks.in? If the DNS resolver, if it is having it, right, it will quickly generate non-recursive query. And hey, I have a record a and the IP address of Tungabhadra networks.in. Please take it. Okay. Once it is received, right, it will establish a connection with the TCP server, server with the destination IP 41, ends with 41, and it will start accessing the data. Okay, because
Why it
DNS,
is you? Why it is using UDP? Why not TCP? It is more secure, no?
man, for queries,
Okay.
see, it is queries. For queries, you need to ask each and everyone, right? TCP is one to one. It
Okay.
establishes a connection with one to one. It is querying to everyone. Okay,
Mhm.
it's UDP. Okay, it is querying to everyone. Okay, it uses a query. It's a query, that's why it uses UDP. And please
Okay.
mention in this in interview. Okay, please,
Okay.
sorry, they will ask you in interview when it will use UDP, when it will use TCP. When it's generating a
Mhm.
queries, it uses UDP. Okay, so
Okay.
now the query, recursive query, will generate to resolver. If the resolver having the IP address of this Tungabhadra networks.in, it will respond with the query, non recursive query, with the IP address. Hey, I have the IP address for this Tungabhadra networks.in, please take it. Now once the computer receives it, right, it will establish a connection with the server. Okay, okay, and and what is that? It will establish a connection with the server, and it will start accessing the data. And now one more thing, what if the DNS resolver doesn't have the IP address of this domain name? If the DNS resolver will not have the IP address of this domain name, what it will do? Again, it will ask a root server. Root server in this is secondary DNS. The secondary DNS is Google DNS 8.8.8, 4.4.4. Guys, these are the Google DNSs. There are total 13 root servers in the entire world here. Okay, you can give anything. Lot of people are using 8.8.8 is the secondary DNS. Now, if your local broadband connection DNS resolver does not have the IP address of this Tungabhadra networks.in, It will again generate a iterative query. Here we call iterative query. It will generate a query. Simple, you can say query to root server. So root server is having 13. There are 13 root servers. It is having all the informations. Okay. First, it will go to the root server. Okay. Now root server says, hey, I don't have the IP address of the domain name tungabhadra However, I know who can you can contact this guy. This guy may aware of it. So it will give the TLS in TLD, top level domain information. Who are the top level domains? This .com, .in, .edu, .co, .in. You remember, right? When you try to access it, any website, you will see .co, .in, .com. My
Yes,
website
yes.
is .in, not .com. Okay, and there are a
What is
lot
the
of
difference?
sorry.
What is the difference?
You can Google it, man. .com is
Okay.
your global. .in is country representation, brother. Okay.
Okay.
.in,
Okay.
.us. You will see, right? .us, right?
I see.
Okay. So you can see these are the things, top level domains. Okay. .com,
Okay.
.edu, .org. These domains, okay, representing the respective, okay, organization or something. Okay, right? So
Right.
those all information will be available in top level domain. So please contact them. They might have the IP address of Tungabhadra networks.in. So DNS resolver again generating a iterative query to TLDs, and TLD says that, hey, I don't have the IP address, but I know authoritative server. It means exactly who have the IP address of this Tungabhadra networks.in, right? I know them. Please contact them. Contact the authoritative server. It's a Tungabhadra networks.in server. So DNS resolver again will send to the query to authoritative server. Okay. First it will send query to root server. Root server it doesn't have, but it knows information about TLD. It will go to the TLD. TLD is giving the authoritative server information. It will go to the authoritative server. Now authoritative server have the IP address of this Tungabhadra networks.in. It gives this IP address to DNS resolver, and now DNS resolver have its own cache memory. It stores it, it stores it, and it's sent to the client computer, and now it establishes a connection with server. Why it stores it? Suppose Ramesh, some one computer is trying to access Google. There are a lot of millions of customers trying to access the Google, right? Yes or no?
Yes.
Yes, sir.
Right? Every time you should not go to the authoritative server and TLD server. It will be huge traffic to them, and the servers will not be responded. If the see when you have an intermediate or results, right? If you're trying to get the results, the server will not respond because of the huge. Everyone is trying to access at the same time. The server capacity is very less. It cannot respond it. So that's why to reduce the burden on the servers, each DNS resolvers means the service providers, whatever the service providers, Airtel, Juniper, sorry, Airtel, Geo, and your local broadband connections maintains the DNS resolvers. Okay, and they have their own cache, and they will send it to the client. Next time, if anyone asking, right, they will respond with the query, recursive query. Understood? Read this PPT, very beautifully written. Okay, okay, very beautifully written, and you know you can you can get it. Do you need this screenshot, guys? Understood, everyone?
Yes, sir.
Yes, yes.
Every
Understood.
understood? Any questions?
డౌట్స్ ఏం లేవు. నార్మల్ అడిగారు కదా అది కంట్రోల్ ఫ్లో ఎర్రర్ అది అది ఇంకేంటి సార్ టీసీపీలో?
TCP you have to learn flow control, okay, congestion control.
అంటే ఏంటి సార్?
That's what you have to learn, man.
ఓకే
Okay,
సార్.
you have to learn, go through it, and if you
ఓకే.
don't
అంటే
able
అది
to,
ఇంకా
so
ఇంకా
you
డెప్త్
do
సార్ అది?
current, yeah, you have to learn
ఓకే.
that. There is very
ఓకే
more
సార్.
depth. Okay, so you
ఓకే
have
సార్.
to learn that. Okay, you just go through it. When trying to read it, you'll get something, and you'll not get something also. Whatever you're not getting it, you come to me and ask me, hey Anna, I read this, and I till this I understood, and after this I didn't understood. Then I appreciate it. At least you're trying to learn something. Okay, so everything cannot be teach, man. Okay, so
ఓకే సార్.
whatever, see, this is how you have to learn. Okay, so this is a task I'm giving to you guys. Please prepare TCP options, flow control, error control, and congestion control. What does it mean? It's very easy if you go through it. Now you understood, right, TCP, so that it will be easy for you. Okay. Yeah. Any questions on TCP? So no, not TCP, DNS.
No, sir.
DNS is easy, right? Just
Yes, sir. Yes,
Yes.
sir.
so just go to the recorded sessions once, you will understand. Just go through the recorded sessions only once, you will understand. Okay.
Okay.
Okay. So
Okay.
this is the DNS. Why I explain TCP? Because DNS uses TCP also, right? You should know TCP. That's why for the first time I explain TCP. Then after I explain you what is the DNS. Okay.
Brother,
So
please send that book also.
sorry.
The TCP/IP book is available.
Yeah, I will send it. I will send it. Okay. Right now I will send it. So guys, please read this PPT. I just explained step by step process here. Step one, step two, step by step process. How DNS works, step by step process. Please read it. Okay. So
Okay,
what
sir.
is
Okay.
recursive query, iterative query? So recursive iterative query between recursive query it is between your computer and DNS resolver. Iterative query between here your DNS resolver to other root servers. Okay. And let's show you the packet capture. So DNS packet capture, let me show you. Okay. I told you, right? Hello.
Yeah, yeah.
Okay. Okay. So currently we are not implementing DNS, right? It's a server thing. There is already packet capture stuff. If you see, right, this is a source IP, computer IP, this is a destination IP. See, it is generating a query. What is that? The port number is 53, layer 2, layer 4. It uses UDP for queries. Okay. See, it is asking query, hey, I need a IP address. See what query it is asking. If you see query, right, I'm expanding it. This is a query. Some .NET. See, this is a query. It is asking IPv6 address. It is generating a query. Understood, everyone?
Yes,
Mm,
sir.
Yeah. Let me open another packet capture. There are a lot of sample captures. See, if you see, right, here the standard queries. Query means it is asking. Okay. First it is asking DNS resolver. Then after it is asking top level domain. See 22.1. See, it's all are standard queries. If you see, right, queries. It is asking I need a IP address. What class it is? Record A. Okay. These are the flags. Okay. Now it's a recursive query. Okay. It's a recursive. Okay. So do query recursively. Okay. So there are queries, man. Recursive query, non-recursive query. So recursive query in the sense it is, computer is generating. See here it is generate. It's set to one recursive query. Okay. Now if you see still recursive query. So we're just asking queries. So we'll see the response. There is a response here. Here. Are you seeing the query response here? Query response. Now you are
yes.
getting a query response here. Here till from here till there are a lot of response now. Let's see the responses one by one. So the query, you will see the answer. See, you queried something and it is getting answer. It is giving answers. Let's check the answers for each and every query. It is asking IPv6 address, right?
Yes.
Let's see where is the response. Yeah, see, it's record A and it is getting the IP address. Yes or no? Right?
Yes.
Answer. You got the answers, right? This is the answer. This is all about TC, domain and system. It is responding. Okay. The server is responding with the response. Okay. This is the address. It is stored in A record. Okay. This is how it works, guys. Okay. It's very simple
Okay.
process. Please read it and they will ask you an interview. No one will tell you this much of deep depth. Okay. So
Yeah.
why? Because it's very important. The step-by-step process is very important. The packet capture also I captured here. Okay. Please read it. Okay. Top level domains, everything. Just download this PPT from our server website and read it. Okay. That's all for today, guys. So we covered TCP as well as UDP. Okay. Yeah.
Mm,
Yeah. So going forward, if you completed whatever the task I have given, so when we discuss about BGP protocol, I will explain this congestion control other things. Okay? Yeah. I will explain if you fulfill my the task which I am giving, right? If you completed the task only, I will explain. Otherwise, it doesn't make any sense to explain. Okay? You have to read every day whatever I'm telling you, right? You have to read it. Otherwise, you cannot understand the things. So the whatever I have said, right, the congestion product, those are the next level topics. If you want to understand that, you make sure you clear this TCP three-way handshake process and the control bits, other things. Okay, you must if you want to be a professional network engineer, please complete this packet capture or what is that packet header. Learn about it, practice it. These are the control bits, source port, destination. What are the fields inside the TCP header? Practice it for 10 to 20 minutes on the paper. Definitely you will be pro. You will become pro. Okay.
Bro, what about that reserved packets? In next class we will discuss. Or?
No, man, that's a reserved. That's why we're not discussing. Those are reserved for some development purpose. Okay, we are not using it. Whatever we are using it, we are discussing it. Whatever we are not using it, why we want to discuss it?
Yeah, waste of
Okay,
time.
and we don't have data also to discuss that. It's a reserved bit. Okay, fine then. Okay, and Google it if you have any queries. Google it first and try
Yeah,
to
yeah, I will
understand.
Google it, but in your aspect, it is different.
Yeah, yeah,
That's
yeah.
all.
Just asking, not now actually. Going
Okay.
forward, if you find something interesting, right, just Google it
Yeah.
and try to understand it. If you don't understand, just call it out here. We can discuss
Okay.
so that
Okay.
everyone also can understand. Guys,
Yeah.
how many people understand today class? Raise your hands. I need your attendance.
అంటే మీరు చెప్పే టర్మినాలజీ అర్థమవుతుంది సార్. అందుకని మళ్ళీ మిమ్మల్ని స్పెషల్‌గా అడగాల్సి వస్తుంది అంతే.
Yeah. Adagandi. That's what I'm saying. Please ask me, but try to do some effort from you. Okay? Just
ఓకే
that's what
సార్.
I'm
ఓకే సార్.
asking. So that you can easily, get it when I'm explaining it. Okay? Yeah, that is how we learn the process. So Pooja, do you understood?
Yeah.
Okay? Please go through this video again. Everyone, Kalyan,
Yes. Okay.
Madhusudan, Mahesh, Malesh, Raviteja, everyone understood. Okay, let's see how many raise the hands. Only 8 people understood. Remaining people don't understood. Anand,
నో, నో సార్. అండర్‌స్టూడ్.
please raise your hands. Whoever is understood, please raise your hands. Okay. So whoever is not understood, go to the recorded session and come back to me. Guys, this is very, very, very important session. Try to understand. If you know this, you will rule the networking. Because who is ruling the internet? TCP and
Yeah.
DNS. Those are the common things. See, these are the internet. Each and every website. Okay. Try to understand the background process. Now you understood, right? I told you what will happen when you type a www.google.com. Now you understood, right? What exactly it will happen? It will generate a queries, try to find the IP address. Once you get the IP address, it will establish a TCP connection and it will access the data. Okay. Okay. That's all for today, guys. Thank you so much. And we'll meet you tomorrow.